2023 ADMA paper 2 question 5. In how many ways can 6 red flags and 7 green flags be placed in a straight line if there are no restrictions? So in this case, we have 6 reds and then 7 greens. And then we want to place them in a straight line without any restriction. So in additional mathematics, I know we normally, you need to be taught whether the 6 red flags are identical or not. The same applies to this. But in additional mathematics, you can just assume they are not identical unless you've been taught so. So in this case, we have 13 flags in total. So since we have no restrictions, the number of ways of arranging these flags will be 13 factorial. So 13 factorial is 13 times 12 times 11 times 10 times all the way to 2 times 1. So now when you punch this on your calculator, this is 13 factorial, you get this big number 6227020,800. So this is the number of ways of arranging these flags if we have no restrictions. And then on part B, so if flags of the same color should be next to each other. So now, if these 6 red flags should be together and the 7 green flags must be together, then technically speaking, we have 2 flags to arrange, because 1, 2, 3, 4, 5, 6, these guys are together. 1, 2, 3, 4, 5, 6, 7, these guys are equally together. So in short, we can either have the green flags first or the red flags first. In short, we have 2 factorial ways of arranging these, but then these 6 red flags can also permuta. You can also rearrange them. So we have 1, 2, 3, 4, 5, 6. So that means we have 6 factorial ways of arranging these 6 flags. And then the same applies to the 7 flags. It's not like they must always be in this order. The only condition here is they must be together. So the order will not matter there. The only condition here is the 7 flags must be together, not that the first one should always be the first and the last one should always be the last. They can also be rearranged in 7 factorial ways. So now to solve this, you can simply say 2 multiplied by 1, that's 2 factorial there, and then multiplied by 6 by 5 by 4 by 3 by 2 by 1, and then you do the same with the 7. 7 multiplied by 6 by 5 by 4 by 3 by 2 and by 1. So now you can punch this on your calculator. So you say 2 factorial multiplied by 6 factorial multiplied by 7 factorial. So you are getting this big number 7257 and then 600. So this is your answer. And then finally we have part B. So on part B we have a committee of 10 people has to be chosen from 6 men and 7 women. So we have 6 men and 7 women. So now find the number of ways of choosing 4 men and 6 women. So remember, the total number of people in this group must be 10. And then we want to choose 4 men So want to choose 4 men, and then the total number of men is 6. So from these 6 men, we are choosing 4. So we have 6 combined, 4, or 6 choose 4, multiplied by, from the 7 women, we can choose 6. So 7 choose 6. So now we shall punch these on our calculators. This is known, this is actually a 7. So we can say 6 choose 4. This is 15 multiplied by 6 choose 5, 7 choose 7, 7 choose 6 is 7, 7 choose 6, that's a 7. And then now you can multiply these two numbers. So we are getting 105 ways. And you are done. So these are free marks, huh?